Every year, people around the world consume over 1 trillion eggs, with some countries averaging more than 300 eggs per person. They're a staple in countless diets, yet most people never think about the scale, precision, and care that goes into getting them from the farm to their plate. So what really happens inside these massive factories, and what hidden steps make sure those eggs arrive fresh and safe? Well, let's uncover it all here at the Process World. Long before automated belts and massive factory lines, eggs were a small-scale affair. Thousands of years ago, ancient Egyptians were already hatching chicks using heated brick ovens, carefully controlling warmth to bring new life into the world. Fast forward to the 19th century, and farmers were still collecting eggs from backyard flocks, selling them fresh at local markets. It wasn't until the early 20th century that things began to change in a big way. The invention of electric incubators made large-scale hatching possible, and by the 1920s and 1930s, poultry farming was starting to move indoors. This shift meant hens could be protected from predators and harsh weather, laying more consistently throughout the year. The post-war era brought even bigger changes with the introduction of battery cages and automated collection systems, allowing farmers to keep larger flocks and gather eggs more efficiently. By the 1960s, industrial egg production had become the norm in many countries, and technology has only advanced since. Today's factories use sophisticated housing, climate control, and machinery to keep eggs moving from the coop to the conveyor belt in record time, setting the stage for the complex and fascinating process that follows. But where does it all begin? Well, before we get into that, please leave a like and subscribe for more amazing videos like this one. Now, moving on. Every egg's journey starts in a place designed to keep hens healthy, comfortable, and productive. Modern poultry farms run with precision. Lighting is timed to encourage regular laying, temperatures are kept steady, and fresh feed rich in calcium ensures strong shells. Clean water is always available, and veterinary checks help catch any health problems early. There's no single housing style for these birds. Some farms use battery cages stacked in rows, others have open barns, and some operate free-range systems where hens can roam in designated outdoor areas. Each setup is managed to control cleanliness, protect the birds from disease, and keep egg production steady. In Gulf countries, many poultry farms rely on fully enclosed housing with advanced cooling systems to counter extreme heat. In countries like Oman and Qatar, feed is often imported, but water and temperature control are managed on-site to keep hens laying consistently year-round. Undeniably, technology now plays a huge role in these farms. One major breakthrough is in ovo sexing, which lets hatcheries identify the sex of an embryo before it hatches. This reduces the need to cull male chicks, which has long been a controversial part of the industry. It's a step toward more ethical production while still keeping operations efficient. Once a hen is healthy, well-fed, and settled into her environment, the laying routine kicks in like clockwork. Most hens lay one egg roughly every 24 to 26 hours, and the process starts deep inside the bird's reproductive system. The yolk forms first, followed by the egg white, and then the shell is built layer by layer with calcium from the hen's diet. By the time it's ready, the egg is a complete, sealed package. On modern farms, this natural cycle flows straight into a mechanical system. As soon as the hen lays an egg, it gently rolls onto a slightly sloped surface and onto an egg belt. These conveyor belts run the length of each row of cages or nesting areas, carrying the eggs to a central collection point. This design means the eggs are handled less, reducing the risk of cracks or contamination. Collection happens multiple times a day to keep everything fresh. Workers and automated systems monitor the belts, making sure nothing gets stuck or damaged along the way. By the time the eggs leave the laying area, they've already had a smooth start to their journey, moving quickly and carefully from the hen to the next stage of processing. In modern facilities, this is handled by automated washing systems designed to treat every egg with care. Warm water flows over the shells, while soft brushes remove dirt, feathers, and any debris picked up on the farm. Food-safe detergents help break down anything stubborn without damaging the shell's surface. Temperature control during washing is critical. If the water is too cool, there's a risk that bacteria on the outside could be pulled through the shell's pores. If it's too hot, the shells could crack. The right balance keeps the egg intact while ensuring it meets strict safety standards. This step is especially important for preventing salmonella and other harmful bacteria from reaching the consumer. Different countries handle this stage in different ways. In the United States, washing and refrigeration are required, meaning eggs head straight into chilled storage after cleaning. In parts of Europe, eggs often skip the wash and rely on their natural protective coating, storing them at room temperature instead. Both methods are designed with freshness and safety in mind, shaped by regional regulations and food safety practices. After cleaning, the eggs move on to one of the most precise quality checks in the process: candling. This method gets its name from the early days when farmers held eggs up to a candle flame to see inside. Today, the same idea is used, only with bright electric lights and advanced sensors. As the eggs pass over these lights on a conveyor, the illumination reveals what's going on beneath the shell. Inspectors and automated systems look for cracks, blood spots, or irregularities in the yolk and egg white. Any egg that doesn't meet strict standards is pulled out of the line right away. This is about food safety. Even a hairline crack can allow bacteria to enter, which is why detecting them early is so important. Recent improvements in candling technology mean machines can now detect even smaller defects than before, giving consumers a better guarantee of freshness and quality. Once the eggs have cleared the candling stage, it's time to sort them with absolute precision. This is where grading machines take over, carefully weighing each egg and checking the shell's strength. These systems work in a steady flow, moving thousands of eggs an hour without missing a beat. Every egg is placed into a category based on its weight: small, medium, large, extra large, or jumbo. The grading process also considers the condition of the shell and the firmness of the egg's contents. Eggs that meet the highest standards, clean shells, no cracks, firm whites, earn the Grade A label and head to retail cartons. Lower grade eggs don't go to waste. They're often sent to processing plants where they'll be turned into liquid, frozen, or powdered eggs for use in food manufacturing, restaurants, or large-scale baking. In some facilities, advanced AI-powered sensors assist in grading, spotting imperfections too subtle for older systems to detect. This stage ensures consistency. When you buy a dozen large eggs, you're getting a uniform product that cooks evenly, whether you're making an omelet at home or a bakery is preparing hundreds of pastries. It's the quality control that keeps every carton predictable and reliable. With grading complete, the eggs are ready for their final presentation. Packaging lines are fast, efficient, and designed to keep each egg secure. Conveyor belts guide them into molded cartons or trays, with each slot shaped to hold the egg firmly in place to reduce movement during transport. Labels are added automatically, carrying important details like expiration dates, farm identification codes, and safety information. This traceability means that if there's ever an issue, producers can track exactly where the eggs came from and where they were shipped. Packaging materials vary. Molded pulp cartons are common because they're sturdy and recyclable, while some producers use polystyrene or clear PET plastic for extra visibility and protection. Whatever the material, the goal is to keep the eggs safe from cracks and preserve their freshness until they reach the store. Once packed, the cartons are transferred to climate-controlled storage rooms. Maintaining a steady, cool temperature here helps slow down any natural changes inside the egg and reduces the risk of bacteria growth. From this point, the eggs are ready for distribution, set to travel to supermarkets, restaurants, and food processors across the country. And that's it. So now to you, if you could redesign one step in the egg production process to make it faster, safer, or more sustainable, which step would you change and why? Share your thoughts in the comments section below, leave a like, subscribe, and turn on the notification bell for more amazing videos like this one.